say preventive maintenance optimization, what we mean is that we are looking at the lowest possible cost, okay, of maintenance to ensure the reliability of our system and thus improved production process. Are we getting it? So that is what we are doing when we say optimizing the maintenance program. We want to give the right maintenance mix, the right proportion of maintenance, the right kind of maintenance, deploy the right kind of resources, okay, to ensure the reliability and improve production of our process or our assets, okay. So if you look at your screen now, you will see that the screen is a graph of cost as against the number of failures, okay. So as you move up the vertical axis, the cost is going up, and then as you move right of the horizontal axis, what happens? The number of failures or rate of failures is increasing, okay. So definitely we know that to improve the reliability of our assets requires money. We need to spend money in ensuring the reliability of, but there is a cost that is not sustainable to our operations. Are we getting it? So we try as much as possible to reduce this cost so that we'll be able to increase revenue at the end of the day and make our operations more sustainable. So if you look at it, this is the total cost, okay. Then we have the preventive cost, and then we have we have the preventive cost and we have the repair cost. So you see that the preventive cost will be high when we have fewer number of failure, because we are doing all we can, spending all we can to ensure that the asset is reliable, deploying all the resources that we can, okay. So you also see that since failure is minimal, the repair cost will be minimal, okay. But like I said, these expenses may not be feasible, so at times we reduce the maintenance, okay, to save some money. But as you reduce the maintenance, you see that you increase the failure rate. Are we getting it? And then the expenses you incur in repairing those or returning the asset back to operational status, okay. So all of this, and you see that at this level, the total cost is high because of the high maintenance cost. Then when you go beyond this point, the total cost is also high because of the high repair cost, because you have reduced your maintenance cost, okay, to as low as possible, and that can result to a failure that will cost you much more. So optimized maintenance program strive to attain this sweet spot where the total cost of maintenance is as low as much as possible, while you are maintaining the reliability or reducing the failure of number of failure of your system, so that your revenue will also increase. So you see that as you move to the right, the preventive, you move from preventive to predictive maintenance, okay. So this predictive maintenance is what will be deployed most, okay, in an optimized maintenance strategy, so that you will see this maintenance program, these failures in their inception stages, and design a maintenance program that will take care of that failure before it ever occurs. Are you getting it? But like we said earlier, there's a limit, at least because of the cost that will be involved. So we want to get the right mix of all of these three maintenance programs. Okay, the preventive, predictive, and corrective maintenance program. Okay, in a well-optimized maintenance strategy. So to optimize our maintenance program, as we said before, we need our failure data, okay, from the equipment maintenance record. Okay, the failure record, your work orders, the equipment maintenance completion forms that was filled out. Are you getting it? So we can also get all of this from the CMMS system if you have one in place. Okay, then your existing maintenance task that you already have in place, you also need to look at them. Okay, now each of these maintenance tasks, you have to review them vis-a-vis the expected failure that you have, or which of them is actually taking care of those failure information that you have from your record, the failure data that you have from your system. So when you review it, you will see that some failure modes, they are handled by some of these maintenance programs, while some would not have maintenance strategy in place to handle those failure mode. While there are some programs that we'll see, maintenance program that we'll see, that is actually not handling any failure mode in the system or in the asset. Okay, so all of those will review. Yeah, then from the RCM principles, once we deploy them, we'll be able to determine the right maintenance mix, okay, that will help us to optimize these maintenance strategies, as we'll see later. Okay, which means that some maintenance, unnecessary maintenance, will be removed. Some will be introduced to take care of some failure mode that the former maintenance program did not capture previously. Okay, of course, we'll now have improved maintenance strategy. So that improved maintenance strategy that we'll have, of course, is subject to review. Any gaps that we see in the review, we use it to improve the process later. Okay, so there is room for continuous improvement. So what do we need to do when we are optimizing our maintenance strategy or our maintenance program? Okay, first, like we said earlier, you identify all the failure modes associated with the operations of that asset. Okay, then once you have identified all the failure mode, you now look at all the maintenance strategy that you have in place too. Okay, and then once you identify all those failure mode, the maintenance strategy determine which failure mode that particular maintenance strategy is taking care of. If you are able to see it and see the feasibility of it, of course, you will let it slide. Okay, that is, you continue with it. But if not, you have to review that maintenance strategy. So you identify the failure mode. That's the first step. Then you now ask yourself, does this condition actually occur during the equipment service life? So what this is telling us is that you are now reviewing your maintenance strategy, the preventive maintenance strategy that you already have in place. Okay, be it condition monitoring or the normal time-based maintenance program. That is the normal preventive, what we used to call preventive maintenance. All of them are preventive maintenance anyway, because in essence, we are preventing or trying to prevent failure. So you now ask yourself, if that failure mode that particular maintenance program is designed for, if it will happen at all in the course of operations of the system, of the asset. So if it is a yes, okay, if it is a yes, we'll come to this later. If it is a no, that means that task need to cancel it, okay? Or a very wrong condition was actually considered, okay, while designing that maintenance task. Are you getting it? So you need to consider the right condition, and that will help us to look at the right maintenance task. Okay? So if it is a yes, then we can look at what type of task that is involved. Okay, so we'll go through, if we have the maintenance steps already outlined somewhere. Okay, usually the planners, they will have that, or we have an SOP. So that will help us to determine the task that will be involved, okay, in carrying out that maintenance activity. So we'll now ask ourselves the next question: does that task already address the failure mode? That is this failure mode. All the things that we are doing, does it address the failure mode? Okay. So that actually looks at the applicability of that task, whether the maintenance task is beneficial in maintaining the inherent reliability of the system. Okay. So if it is a no, we need to change to condition based. When we say condition based, which means that maybe that particular task, when we, irrespective of the fact that we are deploying it, the equipment still fails. Okay, so could there be something that we can do to look at the condition of that component, so that when it is failing, we know? Okay, so we can change that task to condition based, or we rewrite the steps so that we have it to be more effective. Okay, if there are none to be applied, of course, well, we can allow it to run to failure, especially if it is feasible for it to run to failure. Okay, or we can, if it is possible, to create a redundant unit or a parallel unit. Of course, that will help us. If it is feasible, that will help us to improve the reliability of that system. So the next question we'll ask ourselves, is the task applicable? That is, we'll ask ourselves now, and if the task is applicable, what do we need to do? We need to ask ourselves the next question: is it reasonable? Is it worth it? Yes, it's applicable, but look at the cost of deploying this task. Is it worth it? Are you getting it? So if it is not reasonable, we can, if it is a PM task, we can extend the intervals. Okay, when we extend the interval, that will help us to reduce maintenance costs. Okay, or we can make it condition based, as we said earlier. Okay, so that the component does not fail before we actually. So the condition based maintenance will only, we only maintain the equipment when the conditions say that this equipment is due for maintenance. So that will help us to utilize the useful life of those components. Okay, Then, if it is reasonable, that is, the task is justified, of course, the PM task, the scheduled PM task will continue with it, or will schedule that task to be performed. So we'll continue with that task. So after all of this review, see that some tasks are not necessary. Those ones will be removed. Some tasks are too expensive to be deployed. We'll now look for the ones that are less expensive, that will help us to achieve the same result or even better results. Okay, that will help us to reduce the maintenance costs. Then, of course, we will also see that some of these tasks that has been defined in our maintenance program, they actually take care of some failure mode. So those ones we will retain. Okay, and those ones are actually cost effective. So those ones we will retain. So when you do all of this, you will see that at the end of the day, those unnecessary tasks and activities, even there are some that are even duplicated. Take, for example, a particular pump bearing. It is defined in the maintenance program that the maintenance technician duplicates that particular pump bearing. Then it is also in the operator's SOP that during lineup, check the oil level in the pump. Okay, then if it is not up to the required level, top it up. Yeah, so that is actually a duplication, though it's nice, but it's actually a duplication of activities. So, and there is also a danger to that, because when maintenance comes, since he knows that operator will come, so don't worry, operator will come tomorrow in the morning during his normal rounds, he will top it. Then operator will come, will look at it, sees it, and maybe he's not having oil with him. So, or even before he leaves the office, he will say, no need to carry oil, because maintenance will do what? Will top it. So if more than one person is responsible, you see that nobody is responsible. At the end of the day, nobody will be responsible. So we want to ensure that those tasks that are dedicated, that will even increase the maintenance costs, also has the effect of creating problems. So we want to reduce or eliminate such activities, or change the personnel that is taking it. That is another area that we need to look at. Those that are currently carrying out those activities, are they the ones that are in the best position, the best know-how to actually carry out that activities? So those are some of the things that optimization will help us to come out with. Okay. So during the PM optimization task, we select the task and determine the failure mode that task is meant to handle. So we'll now ask ourselves, as we said earlier, is that task needed? If it is no, what will happen? We remove that task. Then if it is yes, we'll ask ourselves the next question. Is the task best? Is that task the best, or is that task the best method or the best task to take care of that particular failure mode? Is it the best fit task or method to take care of that particular failure mode? If it's a no, can we use a predictive maintenance program to see when the failure mode is developing? Because even with this present task that we are deploying on, maintenance task that we are deploying on the facility, that component also fails without us knowing. Okay, so all of this we need to really look at. So if there is no PDN task, can we improve on the PM? to ensure that that failure mode is better taken care of. Okay, if there is none, if the answer is no, then we'll try to modify the task. But if it is yes, then we try to, that is if the PDM is yes, okay, also try to modify the task, okay, modify the task, okay. Now, that task, is it the only kind of task that will be able to address that failure mode? If it is a best fit to us, is it the only task? If it is a no, then if it is not the only, then we can review whether we can combine tasks, okay, so that that failure mode will be better taken care of. Are we getting to improve the reliability of the system? So if it is a yes, then we'll now look at those that are deployed to carry out that task. Are they the best for that task? Okay, are they the best for that task? If it is a no, modify those that are deployed to need to deploy the best for that task. If what they need is the level of training so that they become better equipped, okay, mentally to take up the task, of course, design a maintenance training program for them to take care of that lapses. Okay, so if it is a yes, they are the best, okay, there's no need to change that maintenance task. Okay, so now we have seen that the task is needed. It is the best task or maintenance method for that to take care of that failure mode. Then is the only task that addresses that failure mode. And also those that are deployed presently in our facility to carry out that maintenance task, they are the best for that task. Of course, there's no need to change it. Are we getting it? So what will happen is that we leave that maintenance task. So those are the things that we need to do to optimize our maintenance process. So when our maintenance strategy is optimized, you will see that one, the time to repair, okay, will reduce. So the time to repair will be reduced because most of the maintenance program that will be carrying out, it will be planned maintenance program. And once the time to repair is reduced, the availability, okay, the time between failures will increase. So which means that we will have more products, okay? The production of the assets to do what will also go up. And of course, the failure too will be reduced. So the downtime will reduce with a better planned maintenance strategy. All of this waiting and delays, since most of the programs are the maintenance that we will do, they are planned. You see that all of this will be removed. Okay. Then the uptime, since this is removed, see that the uptime or the availability increase as the downtime is shrinked. Okay. So those are some of the results that we will also get from optimized maintenance program. So what we have is only the range time, and it will be an optimized range time because we know precisely what to do on those times, all that we need. Okay, so you see that we deploy that maintenance activities faster. So once our maintenance program, preventive maintenance PM program is optimized, okay, you see that optimization will make us to have all the necessary parts that we need in place. It's not when the equipment is down that we can start, which is something that is associated with unplanned downtime. So, okay, since it is planned, all the parts will be there for us. Okay, so that will reduce that time that we need to bring parts. Okay, so they see that our maintenance program, okay, will lead the degradation, so that before that component or the asset will enter those wear out period, we have seen it. That will help us to deploy maintenance program to save the equipment or the asset from unplanned downtime, which is usually costlier to handle. Are we getting it, or to fix? Then we also reduce and eliminate downtime from component failure. Are we getting it? So since we know when the component will fail, we plan for it, or before it fails, we do something to restore it back. So you see that we have removed the downtime that will be caused by that component failure. Okay. So PM optimization is one of the pillars on our reliability journey. Are we getting it? And it is something that will also help us to move smoothly into predictive and precision maintenance programs. Okay, and some of the results too, you see that where we need to improve on, we identify then the gaps, the necessary trainings that we need, also identify them and deploy them. So these are some of the beauties and the fine result that comes from the optimization process. Okay.